There are different structures which could be used for register transfer operations. As you can see here, we have a list of them. We could do it using the multiplexer-based transfers. In this case, multiple inputs are selected using a single multiplexer, which is dedicated to the register. So the multiplexer is used in order to select between the inputs and pass one of them to the output, and then that output data will be available to be written into the register. There's also the bus-based transfers. In this case, multiple inputs are selected by a shared multiplexer, deriving a bus that feeds input to multiple registers. We could also use the three-state bus. In this case, multiple inputs will be selected by three-state drivers with outputs which are connected to a bus that feeds multiple registers. Or we could have a combination of those three. So we will go into the details of the last two later, but in this lecture we will focus on multiplexer-based transfers, and we will see how this works. Here you can see an example of implementing that multiplexer-based transfers. We have three registers, R1, R2, and R0 over here. We want to perform two transfers with this configuration. The first one is to transfer content of R1 into R0, as you can see here, and it will be initiated when we have K1 equal to 1. The other operation is to transfer content of R2 into R0, and that will happen whenever K1 is equal to 0 and K2 is equal to 1. So as you can see over here, we have K2 and K1 as the controlling signals. An OR gate is used here, and the OR of K2 and K1 is used in order to determine the load input for R0. So R0 will be loaded when K1 or K2 is equal to 1, and this is OR. If both of them are equal to 1, it will be loaded. If both of them are equal to 0, the content of R0 will not be updated. Then over here, only K1 is used in order to provide the select input to the multiplexer. When K1 is equal to 0, the first input of the multiplexer will be selected, R2, and it will be available here. So here, over here, we will have R2 when K1 is equal to 0. And then while K1 is equal to 0, if K2 is equal to 1, then R0 will receive value from R2. On the other hand, if K1 is equal to 1, then the second input to the multiplexer will be selected. It will be transferred to the output of the multiplexer. Over here we will have R1. In this case, regardless of the value of K2, whether K2 is equal to 0 or K2 is equal to 1, in both cases, R0 will receive value from R1. So you can see that using these two control signals, K1 and K2, we can determine what operation to be performed, which transfer indeed to be performed using a multiplexer. In order to have loading of the destination register, R0, we need to have at least one of them being equal to 1. We can expand these multiplexer-based transfers and go beyond having only two operations. We can have multiple operations. You can see over here that we have control signals, control inputs K0 up to Kn-1, meaning that we have n control inputs. With these n control inputs, we can select among the operations among the transfers or among the operations that we want to have. You could see that we have the OR gate over here to determine whether the R0, the destination register, should be loaded or not. And then an encoder is used together with the multiplexer. The multiplexer here is n to 1 line multiplexer. In order to select among these input lines, the control inputs S0 to Sm, indeed we have m control lines here, would be needed, and the encoder is used to encode the n control inputs to our whole system into m control input lines into our multiplexer. The inputs to the multiplexer could be also classified. We have some dedicated logic. Some part of the inputs indeed are devoted to the dedicated logic, and some of them are devoted to the registers or shared logic. The dedicated logics could be somehow considered as part of the register itself. Those are the operations, logical operations, which would require the destination register itself and not the others. So you can think about incrementing or decrementing, for example. Yeah? But for the registers or shared logic, other registers also are used here, and we may have some part of the logic which is shared among this register and the others. Here you can see the case of using the multiplexer with more details. We have again the two operations that we wanted to have, but we have the quad in the 2 to 1 line multiplexer, which chooses among these 4 inputs. One of these 4 inputs will be selected, and it will be passed to the output of the multiplexer, which then will be copied into the destination register. You can also see here that the clock inputs are also shown, and they are all connected to the main clock of the system.